Located on one of the busiest trade corridors between the United States and Canada, the Gordie Howe International Bridge is being constructed to become the cable-stayed bridge with the longest main span in North America, crossing the Detroit River at a gateway that handles hundreds of billions of dollars worth of goods each year between the two largest economies on the continent. With a total investment of approximately $6.4 billion, the project includes two bridge towers more than 220 meters tall, a main span of 853 meters, and border inspection facilities covering hundreds of hectares on both sides of the frontier. More than just a river crossing, this is a continent-scale infrastructure project designed to resolve a strategic bottleneck that has existed for nearly 100 years within the Detroit-Windsor transportation corridor. In this video, join Mandarin Tech as we explore how the Gordie Howe Bridge is being built to reshape the flow of trade across all of North America. The United States and Canada are the largest bilateral trading partners in the world. In 2021 alone, goods trade between the two countries reached approximately $664 billion, with a large share of cross-border truck traffic concentrated along the Detroit-Windsor corridor, one of the most important logistics routes in North America. For nearly 1 century, cross-border transportation in this region relied primarily on the Ambassador Bridge, a privately owned crossing that opened in 1929 and became a critical link in North America's industrial supply chain, particularly for the automotive industry, where components may cross the border multiple times before a single vehicle is fully assembled. However, as trade volumes between the two countries increased to hundreds of billions of dollars each year, dependence almost entirely on a single crossing gradually became a national-level strategic risk, especially because the Ambassador Bridge does not connect directly to the federal interstate highway system, forcing most truck traffic to pass through inner-city residential neighborhoods before reaching the regional freeway network. It was under these conditions that the Gordie Howe International Bridge was planned as a new crossing located approximately 3 kilometers downstream from the Ambassador Bridge, intended to relieve pressure on the existing route after nearly 1 century of operation. The project moved forward only after many years of prolonged political debate and strong opposition from Manuel Maroon, the owner of the Ambassador Bridge, before the two governments ultimately agreed to proceed with a new crossing to strengthen one of the most important transportation corridors in North America. The Gordie Howe International Bridge is a cable-stayed bridge approximately 2.5 kilometers long, directly connecting Interstate 75 in Detroit with Highway 401 in Windsor. Structurally, the bridge is supported by 2 main A-shaped towers about 220 meters tall, inspired by a hockey stick, an iconic symbolic detail, as the bridge is named after the Canadian hockey legend Gordie Howe. The main span, measuring 853 meters, will become the longest cable-stayed bridge span in North America. The bridge deck is 37.5 meters wide and includes 6 traffic lanes along with a shared pedestrian and bicycle path 3.6 meters wide. A vertical clearance of 46 meters above the water ensures safe navigation for passing vessels. Both ends of the bridge will be connected to large-scale border inspection plazas. On the United States side, the inspection area covers 68 hectares, with more than 30,000 square meters of facilities and 36 inspection lanes. On the Canada side, the inspection area covers 50 hectares, with 24 inspection lanes and 16 toll booths directly connected to the Herb Gray Parkway, which leads to Highway 401. The total project cost is estimated at approximately 6.4 billion Canadian dollars, with the majority financed by the Government of Canada. The Windsor-Detroit Bridge Authority is responsible for the design, construction, land acquisition, and future operation of the bridge. Because Canada is financing the project, toll collection will be carried out on the Canadian side to recover construction costs. The project is divided into 4 main components: the roadworks at the new interchange in Michigan, the United States Port of Entry, the Canadian Port of Entry, and the Gordie Howe International Bridge itself. The project officially began construction in the year 2018 and was planned to be completed after approximately 6 years of construction. In the year 2019, preparatory works for the main construction phase of the Gordie Howe International Bridge were carried out, including the treatment and remediation of contaminated land within the project area. Along the Detroit River, where the ground conditions consist of thick sediment layers and complex hydrological influences, engineers excavated nearly 30 meters down to stable geological strata in order to construct massive concrete foundations capable of supporting the two main bridge towers, approximately 220 meters tall. By December 2020, the tower foundations had been completed, marking the transition to the erection of the tower shafts using an automatic climbing formwork system, ensuring geometric accuracy and construction progress under high-elevation working conditions. After the tower foundations were completed, construction of the bridge towers for the Gordie Howe International Bridge officially began using a multi-level climbing formwork system. On this working platform, teams of engineers and workers simultaneously carried out reinforcement installation, concrete placement, and technical inspections, segment by segment as the tower gradually rose hundreds of meters into the skyline between Windsor and Detroit. Throughout this process, concrete was continuously transported from ground level to the construction position using a high-pressure pumping system through hydraulic pipelines, allowing stable construction progress to be maintained at significant height. At the top of the tower, steel anchor boxes were integrated into the reinforced concrete structure to secure the main load-bearing stay cable system, from which cable bundles extend downward to directly support the bridge deck. After reaching the designed height, the project continued with the completion of the cable anchorage system and the installation of protective tower top components to ensure stable operation under the icy weather conditions typical of the North American border region. The Gordie Howe International Bridge uses a cable-stayed structural system with tall concrete towers and main load-bearing cable bundles, allowing the bridge to span a long main span without the need for piers in the river. From this point, engineers began installing the first stay cable bundles from the steel anchor boxes that had already been integrated into the tower shafts, gradually tensioning the cable strands according to a precisely calculated sequence to stabilize the bridge deck segments throughout the balanced cantilever construction process. Each stay cable bundle was installed in stages symmetrically on both sides of the towers to maintain structural balance as the main span gradually extended toward the middle of the river. The main span of the bridge was constructed over the water using the balanced cantilever method, in which structural segments were progressively installed from both sides of the towers toward the center of the span until they met at mid-river. At the beginning of each construction cycle, cranes installed steel girders and deck beams to form the load-bearing frame of the bridge deck, after which precast concrete panels were placed into position and covered with an additional layer of fresh concrete on top to create a continuous structural system. This process was repeated segment by segment until the two structural arms gradually extended across the river and met at the center of the span, with each deck segment taking approximately 12 days to complete. The closure marked an important milestone after 18 months of construction, when the bridge deck reached a height of 46 meters above the Detroit River. The event was commemorated with a traditional topping out ceremony in which a pine tree was placed on one of the final girders, a construction tradition with a history of more than 1,000 years, and it also marked the moment when the main span of the bridge officially connected the two shores between the United States and Canada. After the main span was closed, deck finishing works on the Gordie Howe International Bridge entered the final stage, including the placement of the composite concrete layer, paving of the roadway surface, and installation of safety barriers along the entire alignment. At the same time, engineers carried out final adjustments to the tension forces of the entire stay cable system to ensure uniform load distribution under long-term service conditions of the structure. In parallel, the lighting system, deck drainage, traffic monitoring systems, and other technical operational equipment were fully integrated, preparing the bridge for load testing before it officially enters service. The entire project, together with the border crossing facilities on both sides of the frontier, is currently scheduled to be completed and put into operation in the year 2025. In addition to the main bridge itself, the project also includes two large border crossing facilities on both sides of the frontier. On the Canadian side, A facility covering approximately 50 hectares will be constructed, including border inspection buildings, bridge maintenance facilities and tolling systems, with direct connections to Highway 401. On the United States side, the border crossing facility will cover approximately 70 hectares and include inspection facilities as well as direct ramp connections to Interstate 75. This will be the first time a continuous, uninterrupted highway corridor is created between Detroit and Windsor. Thanks to the large-scale border facilities being developed in a coordinated manner on both sides of the frontier, the entire Detroit-Windsor transportation corridor will operate more efficiently, reducing congestion and increasing cross-border processing capacity. This completes the final critical link that enables the new bridge to truly function as a strategic connection within the North American transportation network. If the Gordie Howe International Bridge reflects the increasingly important role of cross-border bridges in reshaping modern trade corridors, then on the other side of the world, the Hong Kong-Zhuhai-Macau Bridge is carrying out a similar mission by linking three major economic centers within the Greater Bay Area of China. The Hong Kong-Zhuhai-Macau Bridge is the longest sea-crossing bridge in the world, with a total length of 55 kilometers, connecting the three largest economic centers in southern China into a single megacity. Every year, millions of shipments and passengers have to spend nearly 5 hours at sea to travel between these three cities. The journey may seem short, but it is full of risks. Just one storm can paralyze the entire transport route, forcing ships to anchor for days. The idea of building a bridge across the sea was therefore born, not only to shorten travel time to less than 45 minutes, but also to eliminate the limits imposed by weather and create a stable trade route all year round. From the first blueprint to the day it opened to traffic, the project spanned nearly 10 years, costing between 18 and 20 billion US dollars and mobilizing nearly 30,000 workers who labored continuously at sea amid waves and seasonal storms. That 10-year journey began with the search for an answer to a seemingly impossible question. How can a solid foundation be built in the heart of the ocean? Before the first bridge spans were erected, engineers had to face the greatest challenge: how to place bridge piers in the middle of the ocean, where the seabed was weak and the currents constantly changed. With an average depth of more than 40 feet, thick layers of silt, and year-round waves and winds, laying the foundation became the most difficult and risky stage of the entire project. Only after conducting surveys, collecting geological samples, and performing precise simulations with specialized software, were they able to anchor steel and concrete firmly amid the currents, marking the beginning of the backbone of this sea-crossing wonder. Once the bridge is completed and officially open to traffic, the constant flow of vehicles begins to wear down its upper layers. After several years of operation, the concrete deck, which bears the direct load of thousands of vehicles each day, starts to show cracks, surface abrasion, and localized spalling caused by repeated loading, vibration, and exposure to the marine environment. Repairing and maintaining the concrete deck therefore plays a critical role in ensuring road safety and preserving the bridge's long-term service life. Before any work begins, the maintenance team must verify all approved materials and reinforcement lists, while conducting a daily safety briefing to define work zones, personal protective equipment, preventive measures, and emergency procedures. From the bridges that connect two riverbanks, humanity has dared to dream of linking entire oceans. Each sea-crossing bridge is not merely a transportation structure, but a declaration of our ambition to conquer nature and expand the limits of human intellect. For China, monumental bridges like the Hong Kong-Zhuhai-Macau Bridge stand as symbols of engineering power and the vision to connect the mainland, the islands, and the world. They not only shorten geographical distances, but also narrow the gap between the present and the future, where humanity and technology continue to write the dream of crossing every ocean. And if you want to explore how technology and people are changing the world together every day, don't forget to like and subscribe to Mandarin Tech. where technology is not only introduced, but conveyed as an evolutionary journey toward the future.